The radian measure is an alternative units to use for measuring angles, and probably is a better one, certainly when it comes to calculus. It's a much better angular measure to use. The conversion, I think of it this way. I mean, it really is, pi is 180 degrees. The reason I just think of that is I just see that association a lot better, because I can think of a complete circle as 360 degrees, and I know the circumference of a circle is 2 pi r, so I can associate that 2 pi with a complete circle, just how I have it in my head. So the common ones we will see, all those exact values of 30, 60 and so on, what do they end up being? Well, 30 ends up being pi divided by 6, because remember pi is the same as 180 degrees. 45 ends up being pi on 4, 60 pi on 3, and 90 pi on 2. So there's all our first quadrant. So that's the first quadrant. We move into the second quadrant, then 120, 2 pi on 3, 135, 3 pi on 4, and so on. So 150, 5 pi on 6, and that brings us up to the 180, which is pi. By the way, remember when I say 180 is pi, pi is still 3.14159 and so on, hasn't just magically become 180. What we're really saying is, no, 180 degrees is the same as 3.14159 radians. So don't think, well, pi is all of a sudden now 180. Let's go into the third quadrant. 210, we get 7 pi on 6, 5 pi on 4, 4 pi on 3, and then 3 pi on 2, and then to complete the circle we have 5 pi on 3, 7 pi on 4, 11 pi on 6, and 2 pi. So these are all the common ones we'll see, just like when we were dealing with degrees, those were the common angles we saw, the 210s, the 225s, they came up a lot. But of course there are other degrees. If we had to express 67 degrees in radians, then we'd multiply it by pi on 180. And I'd just leave it as an exact value. If they wanted an approximation, that's when I have to remember, oh no, pi is 3.14, etc., etc., etc. And we'd get 1.1693. So what that's telling me is a radian is actually quite large, think about it. Because if 67 degrees is 1.1 radians, well, 1 radian, wow, that actually is quite a big angle. 36 degrees, then 36 pi on 180, which simplifies nicely to be pi on 5. Going back the other way, well, now I just multiply by that reciprocal, 180 on pi. Pi's cancelled nicely for this one, we get 22.5 degrees. Now something like 111.1, obviously the pi is not going to cancel. Again, that's when we remember, oh no, pi is 3.14, etc., etc. And rounding off, we actually get quite an incredibly large number, 6,365.6 degrees to one decimal place. That'll just do us for today, just playing with radians.